So we're going to look at inverse trig functions today, and we'll look at derivatives of the inverse functions, arcsine, arctangent, arcsecant. Most of these are going to be on your memorization sheet, and we will look at ones that are not directly off of the memorization sheet for examples, mainly because I want to show you how to do ones other than x or other than one variable. So we will look at some other ones as well. We'll start with the idea of a derivative of an inverse function. The way that you're going to solve the derivative of an inverse function is to look at the inverse itself first and then find a derivative. That's the simple way to look at what it is that we're going to be solving. We know how to find an inverse of a function, basic idea from algebra, switch the x and the y, solve for y. You can do that with these problems. There's also on your memorization sheet a derivative of an inverse function kind of formula, I'll call it, on there to look at as well. But that's the real basic way. So we're looking at inverse functions. We'll look at different kinds of inverse functions. There's the trig inverse functions, regular inverse functions. Remember that the inverse function, again, is a real basic idea. Switch x and y, solve for y. So instead of using x, this might be something you might want to look at on your memorization sheet. Instead of using x, we oftentimes will use a u if the problem is going to involve the chain rule, because we know that if it's other than an x, we're going to have a quantity to solve for. So this is a little different than what you see on your memorization sheets. For example, inverse sine of x is simply 1 over square root of 1 minus x squared. It's a full formula to memorize. In u, a u stands for a quantity. So if it were something like inverse sine of x squared rather than just x, we would still do the substitute in the value in place of u. But notice what you see next to it is the du dx. So we have the du dx and the u. We're going to take and replace the u, and we're going to find the derivative of u, just like a chain rule problem. Here's an example. Let's solve it. So go ahead and try it. See if you can figure it out. You're going to replace the u with 8x squared and then times its derivative. If you know your basic memorization rules for inverse trig functions, they're really not that difficult to solve them. It's simply a matter of knowing your basic derivative of whatever you see with the inverse sine function. So I'll give you a minute to try it. Let's see what this will look like. What's our basic formula again that we're going to use? Dustin, what's our basic formula to use? Jana, what's our basic formula for inverse sine? remember that if it's not just an x, we look at the u idea. The u is the 8x squared. We're going to replace that here, so 8x squared goes here, times the derivative of 8x squared. What's the derivative of 8x squared? 16x. Done. If you want, you can put the 16x in the numerator with the 1 on top, so it would read 16x over square root of 1 minus quantity 8x squared. That's it. Just remember, if it's not just an x, put in that value or quantity for x in the formula that you see on your memorization sheets, and then if it's not just an x, you multiply by its derivative. It's a chain rule idea. All right, next example. Oh, there's the solved problem. Let's look at the next example. Right. Next we have derivative of arctangent or inverse tangent. Again, if you want to add this to your memorization sheets, you can. If it's inverse tangent of x, it would simply be, the derivative is simply 1 over 1 plus x squared. Since if it's a quantity of u in this case, we're going to take 1 over 1 plus, replace u with whatever it is, square it, and then times its derivative. That's the du dx, the derivative of whatever u is. So let's look at an example of this one. Find the derivative of the inverse tangent of the square root of x. I'll let you try it for a minute, and then we'll take a look at it. Okay. Need a pen. What do we get? dy dx equals Courtney, what do you got?
1 over 1 plus x and 1/2, and then times the derivative.
1/2
Squared.
squared, good. Times the derivative. What's the derivative? Of x to the 1/2.
Half x to the negative half.
Good. What can we do down below? What is x to the 1/2 squared? X, good. And also, I'm going to show you a couple things you can do with the problem that you might see in the problem. There should be a 1. 2 can go down below. The x, if you bring it down below, it would look like this. And even if you want to go one step further, square root of x. Done. Those are all equivalent answers. All three. All right, inverse secant, it's the same thing every time, everyone. I'm not going to do every single one of them because, again, they're grouped together. They're paired. So you have your 3 basic formulas on your memorization sheet. The difference is one is positive, one is negative. Inverse secant of u. This is the probably toughest one for people to memorize, only because it just looks so funny. You have 1 over absolute value of u, square root of u squared minus 1 du dx. So the formula is you take and plug in the u, so that's a replacement step. And then the derivative piece of it is finding the derivative of u. That's the du dx part. Notice on this one it says the absolute value of u has to be greater than 1. Otherwise, you just simply say no derivative. So let's take a look at this one next. What is the derivative of the inverse secant of 3x minus 4? dy dx. Halsey, what do you got?
Not the right answer.
Well, tell me what you got.
Nothing really. I did it wrong, so.
Well, we're replacing, where's our formula? 1 over replacing our x, so it's 1 over with 3x minus 4, right?
Is this supposed to be like the bond though?
Yep.
Okay, then
Absolute value of,
3x minus 4.
yes, and I see now I'm writing crooked, uphill, but that's okay. Go ahead.
And then the square root of 3x minus 4.
Square root of 3x minus 4.
Squared.
Okay. Yep.
Then minus 1.
Yep. Times du dx. What's its derivative? 3x minus 4's derivative.
3.
Mm-hmm. Yes. Now, here's a big question. Do you think we're going to have to FOIL this? No. You're right. Usually not. It's a lovely written uphill problem. All right, let's keep going. They did on this one, they foiled it. Again, I don't see a real big use of foiling it unless they give you an equivalent problem. Unlike a multiple choice question, I won't worry too much about that. All right, so let's find the derivative of the inverse secant of 6x cubed. Go ahead and try it. Derivative. What is it? Keegan, go ahead.
1 over absolute value of 6x cubed times square root of 6x cubed squared minus 1 times 18x squared.
Thank you. Questions on that one? Ellen?
So like, when you have the 6x cubed and then squared, do you just leave the powers like that? You don't.
It depends on the problem. If you want to write it out, I'll show you. You would do 6 squared, 36, and then power to a power, you multiply exponents, so it would look like this. Okay? The other thing that people ask me a lot is, can I simplify 18x squared over 6x, absolute value of 6x cubed? If you knew for sure, bless you, if you knew for sure that it was positive, 6x cubed, if they told you somewhere in the problem or you knew that it was positive, you could then cancel out or get rid of the absolute value symbol and simplify the 18x squared over the 6x cubed. The book will say simplify, they assume that it is always positive. It's not always the case unless you see it in the problem. So if you see answer simplified from your book, that's why. These you'll want to write down. These are inverse functions of trig functions, what they call the cofunctions. And the reason that you'll want to write these down, everyone, is because some of the problems you won't be able to solve in your graphing calculators and solve them just in general without the cofunction identity. So write these down. These are the calculator. Last one again, like I said with this one as well, are ways that you can either solve it if you don't know a specific inverse trig function. These are calculator conversion identities. In other words, these are ones that you can use in your graphing calculator because there is no inverse secant or inverse cotangent keys on your graphing calculators. Therefore, this is what you'll want to use. Find the other one, like inverse secant is inverse cosine of 1 over that quantity. That's what you'll need to use. These are just, here's another example. This is using inverse cotangent. Again, we don't have to go through and solve every single problem, but I'll show you some other examples as well. This one is using inverse cotangent of x squared. This one is showing using what we just looked at, which is the equivalent to it. We do have a memorization, on the memorization sheet, a rule for inverse cotangent, so you can simply use that rule, which is negative of 1 over 1 plus the function, which is x squared, or the u. X squared is x to the fourth when you square and square it again, and then times the derivative of x squared is 2x. So you don't have to use the rule necessarily unless there's no other way to solve it, or if you'd have to find a slope by plugging in a value to your derivative to get a slope, actual number value, then you might have to use something. But other than that, we have this already, rule and formula on your sheet to use. The main thing you're going to look at today are problems where what we just looked at, inverse trig functions, finding their derivatives, plugging in whatever you see for u, for the x or for the u, and then times its derivative. Questions? All right, I'll give you some problems to try. Section 3.8. Someone have a book page for us? 170? Yeah. Thank you. I'm going to have you take a look at questions 1 through 27 odds. I'll answer questions you have on Monday or today in class if you have questions.